Hello, this video is for IXL Activity 8.F.15. It is titled Square Roots of Perfect Squares. And the 3-character code for this activity is 9 Romeo Sierra. Alright, so square roots. Whenever we talk about square roots and what is a square root of a number, we consider the number that's underneath the radical sign. We call it the radicand. The number that's underneath the radical symbol is called the radicand. So we need to find a number that if it's multiplied times itself would equal this number. Well, in this case, if we know our 3's, we know that 3 times 3 equals 9, so therefore the square root of 9 equals 3. The whole idea is we're trying to find some number that when multiplied times itself, that it will indeed equal what the value of the radicand. In this case, 3 times 3 is 9, so the square root of 9 is 3. Now there is another value, and that is -3. We could also do -3 times -3 equals a positive 9. However, right now in this activity, we're only considering the positive roots. So don't worry about the negative roots of a number right now. Next question, what is the square root of 25? So what number multiplied times itself equals 25? Well, we know that number is 5 times 5. 5 times 5 equals 25. Therefore, the square root of 25 is 5. On the next one, what's the square root of 100? Well, we know that 10 times 10 equals 100. So in this case, the square root of 10, or square root of 100, is indeed 10. What's the square root of 36? Well, what number times itself equals 36? And that indeed is 6 times 6. 6 times 6 is 36. Therefore, the square root of 36 is 6. What about the square root of 1? Well, in this case, the answer is actually going to be the same as the radicand because 1 times 1 equals 1. So therefore, the square root of 1 is indeed 1. How about the square root of 0? Can we find the square root of 0? Well, 0 times 0 actually equals 0. So therefore, the square root of 0 is 0. So in the case of the square root of 1 and the square root of 0, the square root is actually equal to the value of the radicand. Remember, the radicand is the value that is underneath the radical symbol. All right, bigger numbers like 169. Many of us probably don't have memorized past maybe 12 times 12. 12 times 12 is 144. So we could start guessing and checking. Well, I noticed that the ones place has a 9 in it, and I know that these are perfect squares. So it's going to be a non-decimal number, means it's going to be a whole number, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so forth, right? So in this case, I know it's greater than 12 because 169 is greater than 144. And I'm thinking 13 because 3 times 3 is 9, right? And there's a 9 in the ones place. If I do 13 times 13 and I multiply those numbers together, 3 times 3 is 9, 3 times 1 is 3, and 1 times 3 is 3, and 1 times 1 is 1. So if I add all this together, I end up with 9, 6, 1, and sure enough, 13 times 13 equals 169. So the answer is 13. Now, I could check my answer using a calculator, and I'm going to go ahead and pull a calculator up. We're going to talk about how do you use a calculator to find the square root of a number. And if we look around on the calculator, someplace on here there is a square root symbol. And if we look long enough, we'll find it right here above this x squared button. But notice that it's blue. That's because in order to get the square root, we need to use the second key up here. Notice the second key is blue, and the square root sign is blue. So the second key, it's kind of like a shift key on a computer, a keyboard. If you want to use a capital letter, you have to click shift. Or if you want to use a % sign, that's above the 5, you would have to click shift and hold the shift down and select number 5 to get a % sign. Well, this is kind of the same idea. So we're going to hit the second key, and then we're going to hit this key here so that we can get a square root sign, and you see that the square root symbol comes up. Now we want to put in the value, that is the value of the radicand, the number that's underneath the radical symbol. And we'll type in 169, and then just hit enter, and indeed, you see that it's 13. Here, let's go ahead and use a calculator for this next one down here. Square root of 256. So let's hit that second key to get the square root sign. and then put in 256, and hit enter, and indeed that answer is 16. So that's how you would use a calculator to find the square roots if you wish to do so. But 16 times 16 is 256. Oh, here's 144. Remember a while ago I said that 12 times 12 equals 144. So indeed the square root of 144 is 12. Not 14, but 12. All right, square root of 196. Well, notice that 169 was 13. So let's try 14, and that's probably going to work well because 4 times 4 is 16. So the number in the ones place is going to end up being a 6 if I multiplied 14 times 14. So let's go ahead and do that. 14 times 14. 4 times 4 is 16. Carry the 1. 4 times 1 is 4, plus 1 is 5, and then we're going to get 14 down here, and we'll end up with 6, 9, 1. Indeed, 14 times 14 is 196, so 14 is the square root of 196. What about the square root of 2,500? Well, this might seem somewhat difficult, but if we think about it, not really. Let's focus on the 25. We know that the square root of 25 is 5, right? Square root of 25 equals 5. But we have 2 zeros here. Well, 10 times 10 is 100, and 10 has 1 0, and it produces 2 zeros. So what if we took that 5, that's the square root of 25, put a 0 on the end, then if we did 50 times 50, well, let's see what happens. 50 times 50, 0 times 0, 0, 0 times 5 is 0, 5 times 0 is 0, 5 times 5 is 25, and indeed, sure enough, we get 2,500. So these large numbers ending in double zeros, not really as difficult as we might think they are. Let's use that same concept down here. Let's eliminate 2 of the zeros and just focus on the 100. Well, square root of 100, we know is 10. 10 times 10 is 100. Now let's put one more 0 on there, right? And we would end up with 100. I was just using one of the 2 zeros that we have here on these last 2 zeros. Now we could always check that. 100 times 100, and I'm going to have 0, 0, 0, 0, 0, 0, and 0, 0, and 1 times 1 is 1. So I end up with 0, 0, 0, 0, 1. I end up with that same 10,000 that I have up here for my Radican. All right. Now another way you could approach this is to Google, just type in and do a web search and Google list of perfect squares. I've done that, and this is what I came up with. This is one of the examples here. So it gives you 1 all the way through the first 20 perfect squares. Anything from 1 times 1 all the way down to 20 times 20. So this is a list of the first 20 perfect squares. So something like this would help with this particular activity, right? So you can either calculate it and guess and check and multiply numbers together to see if you get the value of the Radican. You could use a calculator, or for some of these problems, several of these problems actually, you could find a list of perfect squares and refer to that list. All right, so those are all of my examples for IXL Activity 8.F.15, Square Roots of Perfect Squares. Good luck with your activity.